Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. I've got a couple of announcements before we start the show. There's still time to register for the O'Reilly Strata Conference in San Jose, California, happening from March 5th to the 8th. Use the link dataengineeringpodcast.com/strata-san-jose to register and save 20% off your tickets. The O'Reilly AI Conference is also coming up, happening April 29th to the 30th in New York. It will give you a solid understanding of the latest breakthroughs and best practices in AI for business. Go to dataengineeringpodcast.com/AICon-new-york to register and save 20% off the tickets. Also, if you work with data or want to learn more about how the projects you have heard about on the show get used in the real world, then join me at the Open Data Science Conference happening in Boston from May 1st through the 4th. It has become one of the largest events for data scientists, data engineers, and data-driven businesses to get together and learn how to be more effective. To save 60% off your tickets, go to dataengineeringpodcast.com/ODSC-East-2018 and register. Your host is Tobias Macy, and today I'm interviewing Will McGinnis about the relationship and boundaries between data engineers and data scientists. So, Will, could you start by introducing yourself?
Yeah, sure. Thanks for having me on. So my name's Will McGinnis. I'm the chief scientist at Predicto. We're a startup in Atlanta. We have a software platform that helps big industrial companies predict failures in large transportation assets. So planes, trains, cranes, that kind of thing. And we do that by taking in a huge amount of sensor data and maintenance data and all types of kind of messy, maybe not as managed as one would like data. And we clean it up, we merge it, use our machine learning engine, and try and tell somebody what they need to do ahead of time. Other than that, I do some open source work. So I'm a maintainer of categorical encoders, which is a scikit-learn contrib project.
And do you remember how you first got involved in the area of data management?
Yeah, so I fell kind of into it, maybe you could say backwards. My educational background is mechanical engineering, so I did undergrad and graduate school in that. And my research was in trying to predict wear-based failures in different aerospace components with physics models. So we would, go do these experiments and have, huge amounts of time series data and try and build some model that helped to predict it. And around when I was finishing that up, I met the founders of Predicto and ended up joining as first employee. So really early on, I got to wear a ton of different hats. So I was kind of trying to do the machine learning part, but you have to do all of the data management parts before that. So for the first couple of years, most of the work was really trying to build out a good data pipeline, data management. How are we going to take in all these different kinds of data without, going through a different data management process for every customer? And, we learned a ton as we went along, but we were kind of doing it on the fly.
You recently wrote a blog post about the tendencies of data engineers and data scientists, and given the fact that you started off as the first hire at Predicto, I'm sure you got to wear both hats for quite a while before you had enough people that it made sense to actually split out those different responsibilities into separate roles. So to start with, I'm wondering if you can just explain your definition of the terms data scientist and data engineer, given the fact that they're often very overloaded and people will use very fluid definitions when they're referring to each of those different roles.
Yeah, absolutely. I mean, I think they tend to be kind of fuzzy titles, but I try to think of them in really any job title in terms of the domain of work that you're doing and the methods that you're using, right? So think a civil engineer and a mechanical engineer are both doing engineering work, but in two different domains. A data scientist and data engineer are in the same domain. They're both dealing with data problems, data analysis, data systems, but the style of work that they're doing is different. Engineering work and science work are, very different in terms of how you manage them, how you scope different things, how you require gatherments, or if you even can. So the domain and the things that you're dealing with are very similar, and there's a lot of overlap. I think most people do a little bit of both. But when it comes down to actually trying to manage your tasks and decide, what am I going to do this week and how am I going to let people know what I did, they're very, very different. So, I think it applies to basically any job, especially in software, where I think we like to pick a lot of different, really granular job titles. Often, I think picking tools. So somebody will say, like, I'm a Hadoop engineer or something like that, which I think is maybe a little bit strange. But I think the main takeaway is that understanding the workflow of science and data science kind of work versus engineering. So Agile may not be particularly useful for data scientists if you can't really scope the work that you're doing accurately enough to be very reliable. That's the first order of understanding for that.
Yeah, I could agree that identifying your role by the tool you use is rather strange, because you can kind of think of it as if a carpenter were to use the same approach. They could say, oh, I'm a hammer engineer, and that person over there is the saw engineer, where you're ultimately working towards the same goal, and it doesn't really make sense to be so granular in separating how you do your job.
Right. I think it comes down to just both roles are dealing with data and care about data. At the end of the day, I think most of the time the customer of the data engineer is the data scientist, where the customer of data scientist is probably some business unit or some business owner. And, day to day, how one organizes their tasks and decides what to do is, a data scientist probably is popping things off of a queue and they're not really sure how long this task is going to take, or it's very iterative. Data engineers can kind of scope things up into more granular little tasks and share them amongst their peers more easily.
And when I was reading your post, too, one of the things that stood out is that when people use the term data engineer, a lot of times they'll use that to refer to somebody who builds up the data pipeline and is responsible for all of the data plumbing. And the data scientist is usually the person who's seen as the one who's communicating with the business about what the data means and actually creating the presentations of it. But using the sort of description of the role as the engineer is the person who takes the domain and makes it predictable, it opens up the idea of that role to being able to be somebody who actually does create the front end of the presentation layer as well, where you may be stewarding the data all the way from collection through to presentation, but you're not necessarily doing the exploratory aspects of understanding where to find additional sources of data or creating new ways of interpreting that data. You're just working on making sure that all the different steps that the data takes is predictable and repeatable, and that may even include being the person who creates that presentation to the final business user.
Yeah, exactly. And I try to think of the separation between data scientists and data engineers also in terms of what physical thing they're going to hand to one another, right? So if a data scientist, is going to develop some model in Python and, send over some untested script and kind of throw it over the wall and say, all right, go figure this out, that's maybe not a great collaboration for anybody, right? The kind of joint role that they have is as two teams or two people, or even if you're just one person trying to separate things, is to make a neat integration point where the data engineer is enabling the data scientists to do the analysis they need to do and put something into production, but they're not going to completely upend their own data pipeline for it, right? You don't want to have to do a full deploy of something just because somebody needs to update a model, right? So that takes kind of some advanced thought, and you need to architect your system so that data scientists can do their job without disrupting the data engineer's job.
And one of the things that I was noticing too as I was reading through your post and preparing for our conversation today is I see a lot of parallels between the way that you describe the relationship of the data scientist and the data engineer and the same relationship that occurs between developers and systems administrators, where developers and data scientists are agents of change, where they want to be able to iterate quickly on things and see the work that they do get released to production without necessarily considering all of the structural components that come into play in order to enable that, whereas the data engineers and the systems administrators are more interested in restricting scope and creating reliability and consistency. And so there's this point of tension between the two roles and responsibilities where they're all ultimately working towards the same goal, but they're going about it from opposite ends. So I'm wondering if you have sort of drawn the same parallels or if you have any thoughts on that idea.
Yeah, absolutely. I mean, I think it's an extremely similar dynamic and one that comes up directly here as well, right? So if you have completely separate operations, data engineering, data science, and like application development teams, they're all going to be in some kind of tension with each other, right? Especially in the data scientist needs, the data engineer needs operations kind of pipeline. And I don't know that in any one organization there's like a real magic bullet there. The trade-off is the more separation that you're going to have between them, the more that you like treat the other group as a customer, you risk losing some of the kind of the cross-pollination, right? So you'll maybe miss out on some good data engineering idea that could have worked its way into the data science group or vice versa, but you're probably going to ship more and ship faster. So trying to find that balance and where your product maturity is at that time and how that might affect where you want to be in that balance, I think is kind of a constant struggle for anybody.
And have you seen very many instances of people taking some of the philosophies from the DevOps movement and bringing them into the realm of data in terms of sort of fostering that collaboration between the two groups to ensure that you don't create as much of that point of tension, so that each side is trying to build up empathy and understanding for the needs of the other side to ensure that they're delivering the business value rather than focusing solely on their own responsibility and potentially to the detriment of the organization as a whole?
Yeah, I mean, I think it's happening. I think it's maybe a couple of years behind what you see in the DevOps area. There's a number of projects or companies kind of working on this. Let's enable data scientists directly to put things into production. And I think for a lot of projects that makes a lot of sense. But for things at like very, very high scales or things where you're dealing with external data, I think you're going to always end up with, two separate groups or two separate people or whatever it is. And there will be this kind of almost negotiation on, how much freedom do you let the data scientists have at the cost of engineering, at the cost of ops? And I'm not sure that there's really a free lunch to be had there, other than trying to be diligent about managing it and understanding that it is a trade-off that you need to consciously make.
And in your experience, have you found that there is any sort of consistency in terms of the size and scale of an organization or a problem domain that creates the tipping point where you start to need to separate the two roles into separate responsibilities, or having more than one person on a given team versus having the data scientist do both the engineering and the exploratory aspects of it?
So I think the scale at which you want to split them is pretty low, honestly. I mean, especially if there's travel involved for the data scientists. If you're traveling every other week to go see a customer or to some business unit or something like that, I mean, it's just hard as a person to be traveling and dealing with something closer to ops like data engineering. And like I said, the workflow is different enough that it can be kind of hard to context switch between something kind of exploratory and iterative and kind of just cranking out more, I guess, normal engineering work. I don't necessarily think that one's really harder than another, but at least for me, I do a lot better if I have to do both things, doing all of one on one day and all of one on the other day. It's a very different kind of headspace to be in. So I would say even if you're a one-person team, splitting, kind of your understanding of the two types of tasks across different sprints or different days is, beneficial and worth it.
And beyond just the ability to gain efficiencies by splitting those responsibilities, are there any other benefits that you've seen by separating the data engineering and the data science roles into separate sort of problem spaces or job titles within a company?
I think it can kind of foster, so separating these things out pulls you out of the weeds a little bit as an engineer, and you can be, or a data scientist, and you can maybe more readily find parts of the stack that you could replace with something open source or some product or something like that. Where if you're kind of getting into this hack mode where you're kind of doing the science work, which is, very broad and exploratory, and the engineering work where you're kind of just serving your own descent down the rabbit hole, I think it's a lot easier to end up with one-off solutions, right? So having that tension where there's somebody there saying, like, I'm the engineer and I have to support this, we have to put some boundaries on things, I think is overall healthy.
Yeah, and sometimes the best solutions to a problem occur because of the constraints that are being placed on the sort of capabilities of delivering a given solution.
Yeah, exactly.
And have you noticed any particular disadvantages in having the responsibilities separated among multiple people?
Yeah, so anytime you put some restriction on collaboration, which I guess at the end of the day this is, you're going to risk, missing out on some good ideas. So data science and data engineering, while they're very different kind of workflows, you're in the same domain, right? You're maybe a little bit more specialized in one aspect than another, but a lot of really good data science work comes out of data engineering and vice versa, right? So I think if you have a somewhat larger teams, it's really important to have, at least one person that's showing up to planning meetings for both, that's facilitating some free flow of communication between the two. You don't want to make engineers be in twice as many scrums or whatever it is, but whether it's a product manager or just one engineer or data scientist that's going to be the go-between, keeping that open is going to help reduce risk of a data science group beating their heads against a wall on something that data engineering has a solution for, or vice versa.
And are there any particular strategies that you've seen to help ensure a successful collaboration between data engineers and data scientists, or any particular tooling or platforms that you've seen that help to foster that relationship and make it easier for them to collaborate?
So I think the simplest and first thing to make sure you have is, if you're a data engineering team, build out whatever you can to decouple data science's work from your deploy pipeline. So if every time they want to put something new into production, you have to do a deploy, that's really disruptive to both teams. So building, config-driven, well-tested pipelines where they can change a config and you don't have to rerun a bunch of builds and maybe have downtime or whatever it is for your system, I think is the first enabling step to kind of give both groups their own autonomy.
And how do you view the roles evolving as they become more prevalent across more companies and more industries?
So it's interesting. I mean, we've been in a lot of very large, maybe not traditional software organizations and seen how they've done it. They're very, very different company to company, how they just organize data science, data engineering teams. So I think one thing that I've kind of wrapped my head around, I guess, I think data engineering will be centralized and in the IT organization. So I have one big data engineering group that sits like within corporate, and maybe as they get bigger, they're starting to put individuals into business units to kind of go upstream in the data. But all of that will be centralized. The data science groups, I see basically every possible place in an organization they could sit. It might be corporate, it might be its own business unit, it might be all external, there might be one in every business unit. I think over time we're going to see data science groups align much more closely with the end business units. So you'll have a small data science group in every business unit of a big conglomerate, but one data engineering group.
And one of the things that I've seen too is that as the principles and ideals behind data science, and in particular machine learning and artificial intelligence, become more common and more practiced, there are a lot of patterns that are emerging and tooling that is coming out to make it easier for people who aren't necessarily as well versed in the underlying statistics to be able to take those concepts and put them into production and be able to deliver value to the business. So I'm wondering if you see the role of the data scientist becoming more specialized as some of those tools come into the domain of the data engineer to be able to deploy those solutions on top of existing data without necessarily having to engage a dedicated data scientist for a particular problem. And then also in the reverse, a lot of these platforms for being able to collect and process data are becoming easier to run, and there are a number of cloud providers that are actually starting to produce managed solutions that make it easier for data scientists to have more of a one-click deploy solution to be able to gain access to all of the data that they need to be able to do their exploration and experimentation.
Yeah, so this is very interesting to me. I think the root problem here is, I think, frankly, that data scientists are expensive, right? And there's a lot of value that they bring, but they're expensive. So you see two big pushes in industry. On one end, there's this kind of idea that we should democratize data science and enable less technical people, like business analysts or people just in the regular business unit that are like maybe a power user of Excel or something like that, to apply machine learning in their existing roles. And then on the other end, you have this camp that's kind of saying, well, just applying machine learning is not really the difficult part so much. So what can we do to need fewer data scientists, right? So instead of saying, how can I get more cheaply? How can I do more with the 5 or 10 or however many that I have? I tend to think that that is probably the approach that'll win out in the future. I think at the end of the day, the hardest things for a data scientist are really like problem formulation, selling projects internally, convincing people that this magical black box is not making things up. More soft skills and validation, things like that, than in just training a big regression model. So I tend to think that tools that enable a highly qualified data scientist to do 10 or 100 times more projects in a year versus tools that help somebody less qualified do 1 or 2 models a year will win out in the long run.
And one of the things, too, that you briefly highlighted is the fact of the expense involved in keeping a data scientist on staff. So I'm wondering if you have any sort of anecdotal evidence of the relative cost or the relative salary brackets for data scientists versus data engineers, and how you've seen that evolve as the roles have started to gain a more sort of consistent idea behind what those responsibilities happen to be.
I think overall the salaries are, at least in Atlanta, relatively comparable, with the caveat that the base qualifications for data scientists tend to be higher. So a lot of places, it's all PhDs, so they're kind of starting out already mid-career or in a little bit higher bracket. So if you just kind of like lop off the new grad pay range from data scientists, that does still exist for data engineers. And then after that, I think they're fairly comparable. But I don't know. It's hard to say because there's such murky titles in practice that data scientists could be anything from a business analyst to somebody pioneering research somewhere, and data engineer could be anything from a BI analyst to a core committer in Spark or something like that.
It's always a complicated question when you're trying to understand what the salary ranges are for a given job title, again, because they're so nebulous depending on who's writing the description and who's actually doing the work. And one other question that I have is in terms of the sort of portability of the skills, where I'm wondering if as the sort of responsibilities of a data scientist comes to be in broader demand, whether you see the sort of prevalence of full-time data scientists within a company becoming less the norm, and it being more of a sort of contract-oriented role where a data scientist will come in, understand the needs of the business, work to try and understand what the data needs are of the business, and then be able to hand off some of those responsibilities to in-house data engineers. And if you see the data engineering role as being something that's more of a permanent fixture of a company in terms of maintaining their existing data systems and ensuring that they're continuing to operate as needed.
I could absolutely see that. I mean, I think data engineering is a pretty natural alignment with just normal IT operation. So I don't really see that moving to a contract thing. For the most part, data scientists, your goal as a data scientist, I think, is to become an expert at not having domain expertise, right? Because if you lean too hard on the domain expertise, then at some point you're just an engineer in that domain who also knows machine learning, right? So I think as the tooling that people use and the data systems kind of standardize a little bit more in the larger companies, I could see data science moving to a more kind of hired gun sort of scenario. Right now, I think everybody's data pipelines and the way that they're organizing data is so different company to company that you'd lose a ton of time just getting up to speed on everything. So I think things will stay in-house for a little while.
Are there any other aspects of this topic that we didn't explore yet that you think we should cover before we start to close out the show?
No, I think we covered just about everything I thought about.
So for anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And as a final question, I'm wondering from your perspective, what you view as being the biggest gap in the available tooling or technology for data management today?
Yeah, so I work pretty heavily in the Python scikit-learn kind of ecosystem, and I would love to be able to neatly package a trained model, but also with all the dependencies for that model in a separate namespace. Because right now you can train a model, you could use joblib or pickle or something like that to serialize it. But as soon as you load it back, if you've got different versions of scikit-learn and NumPy and SciPy and all these other things, you kind of hope it'll work, and a lot of the time it will. But I think we're still lacking a really good way to reliably save old trained models and use them later. And in a big recurring machine learning system, it's pretty critical so that you can version old models and fall back to them if something's wrong. So I think for me, that would be huge.
Yeah, I think that one of the hopes is that Docker will continue to be sort of the panacea for that kind of problem area, but repeatability and reproducibility in computing in general has been sort of the consistent bugaboo for anybody trying to actually produce any sort of software and run it in a production context.
Yep. And especially with these scientific libraries where you're pulling in God knows how many dependencies and system libraries and all these things under the hood, just kind of having everything of the right version at the right time over the span of a few years is very difficult.
Absolutely. All right. Well, I really appreciate you taking the time to share your thoughts on this subject area, because it's definitely one that is important for a lot of people to be thinking about and trying to understand so that they can be effective in their roles. So thank you for taking your time, and I appreciate the work that you're doing. So I hope you enjoy the rest of your evening.
Yeah. Thank you for having me. I enjoyed it.